barter system that I am just about to describe to you is not yet implemented in any of the wind farms in India. We do not have any wind farm in India which is on which the utility is able to completely rely. That means wind is the only source for that farm. That is not the case in India. But these are, I will talk about 3 different wind farms in Massachusetts in US where we actually implemented them. And these 3 wind farms were around 400 miles apart from each other. So the concept is very simple. If you think about olden times, think about the barter system. That is, if I produce oranges and you produce apples, we don't try to, I'm producing oranges, you are producing apples, but we want to eat both the fruits, right? So I don't go and purchase apples from the market. I would take from you. And you don't go to the market to purchase oranges. You will take from me. So we will have an agreement. Let's say 3 apples is equal to 5 oranges, whatever. And then our needs are shared by that. So that at least on these 2 products, we do not rely on others. This is called barter system. So the same kind of thing, if a wind farm, or let's say 2 wind farms, for example, if they are pumping power to the same utility grid, that means they cannot be very far apart. Very far in this, in the context of utility grids, is, you know, let's say some 150 and 200 miles, 500 miles maximum. Okay, so the idea here is like this, that I have a wind farm which all the turbines here have their own BESS. Now, instead of doing the charging, discharging of the batteries and shortfall and surplus managing by myself and the utility, I also bring in, or we have a cooperative sort of work, that is bartering. That means sometimes I don't do charging, discharging of my own batteries. Sometimes what I will do is that I will, let's say I have surplus and this guy wind farm 1 has surplus and wind farm 2 has shortfall. So what we will do, so wind farm 2 has shortfall. So on his behalf, I will supply to the utility grid. So how does it help? It helps because I don't have to do pumping into the battery, my surplus, and this guy doesn't have to take from the batteries. So I'm charging and he is discharging. So both these things are avoided, and what we had promised, okay, or the guaranteed power which have to be given if you have wind as the only source, what was promised to the utility is handled, because if I have more, I will give more than what is surplus. That surplus on behalf of wind farm 2, I will provide to the utility. So in this way, so there is a proper data management of this, who provided how much for entire year. And then, so that way the cost is more. Why like this? Because if you promise something and you fail to deliver, then there is a heavy penalty, okay, in this system. So that penalty is avoided by doing this bartering. So this was the idea. Okay. So here, these I have already spoken how about this concept and the challenges. So I will move ahead, and basically these 3 I already spoke that we have 3 things here. One is the forecasting algorithms, then the decision making or multi-criteria decision making algorithms, then enhancement of the battery life. Okay, automatically it gets enhanced because I will reduce the number of charging and discharging, because I will also borrow from the neighboring wind farm. Borrow means he is not giving to me, I am not giving to him. He, on my behalf, he is giving to the utility, or I am giving on his behalf to the utility. So this, what this does is that it reduces the burden on the batteries. Okay. So, but it is not always possible. I give you one example where it is not possible. If both of us are in shortfall than what we had promised, so at that time we have to take from our own batteries. Okay, but if we can reduce the burden on the batteries, then the life of the batteries increases, and the overall cost of managing the wind farms is reasonable and profitability increases. So basically, I want you to actually understand this Venn diagram very well. If you understand this, then definitely beyond this lecture, you can explore different aspects. So there are so many different research problems that one can work on in this one slide itself. So many things are there. So 3 things: wind forecasting has to be there. Wake management, I will talk about. Those of you who are not familiar with wake, I will talk about what is wake in one of the slides. That has to be done, and decision making using multi-criteria decision making algorithms have to be done. And all these 3 things together, when we do, we get an integrated solution. Okay, so first of all, we need to do forecasting. I explained to you why we need forecasting, because the utility will not be satisfied if I just randomly at any given jitna ichha hua utna dal diya. They will not accept it. I have to say ahead of time what I will provide. Then only it is a reliable source, right? So, and I should be, if I don't generate at that time that much, I have to supply from the batteries, or some other wind farm has to supply on my behalf, this kind of thing. Okay, so for forecasting, we use wavelet transform as the fundamental building block, and generally we have used different variants of support vector regressors. We find that for short-term wind forecasting, which is generally in Europe and US, it is now well accepted that 10-minute forecasting, 10 minutes ahead. That means if I want to, I have to tell that at 12:10 p.m. I am going to pump this much power to the utility grid. If I at 12:10 I will pump this much, I have to tell that at 12 o'clock. So 10 minutes ahead, I have to tell what I will deliver. Now, I said something, I will deliver. Now, when 12:10 happens, actually that time comes, 12:10. At that time, so I had 10 minutes ahead. For 12:10, I had promised something, right? So at 12:10, there will be an actual delivery, right? Now, if I provide anything less than that, there will be penalty. If I provide more than that, then it may be balanced at some other time. Okay, if I don't have a proper management of data management, then sometimes if I supply more, I don't get any credit for that. So a lot of challenges like that are there. But with proper advanced machine learning algorithms, I can make sure that my error in what was promised and what I actually deliver is less. Okay, so that's the idea. So for this, at that time, we had a project from Niskayuna, that is GE has, General Electric company has 5 different research labs in India at GE Bangalore, GRC Bangalore, we were part of that, and Niskayuna in New York were our counterparts. And there, so we visited there, and from there we visited these 3 wind farms: Paxton, Bradford, and Bishop and Clark's. And so there are 3 of these, and Sotavento in Spain. This data, so these 3 are these 3, Paxton, Bradford, and Bishop and Clark's, the data from that we had access because we actually worked on that. But Sotavento, this wind farm, anyone today, you can go to this website, you can just search Sotavento wind farm Spain, and they are providing a lot of wind farm data. relevant data. Okay, so with these 10-minute windows and all, so the maximum speed, minimum, okay, of that data set, standard deviation, mean, all these data you are able to find. Okay, so now so there are two things. One is that these three wind farms which are in a particular vicinity, they are useful for this algorithm that that means this structure. For that we needed wind farms to be nearby, but we also need more data to actually test how a particular wind farm behaves, whether it is product, whether it can make financially, whether it can make money out of this scheme. So for that we need a lot of data, and that's why we use this Sotaventos. So that's why we have 4 different data sets. So with that, once you have the data sets, we need to have some metric to analyze what is the quality of our forecast. Okay, so for this we need these are standard metrics: RMSE, SSR, SST, U1, U2. Okay, these are standard metrics for analyzing the quality of any data set. We applied different variants of support vector regressor. We found across all these 4 different wind farms that support vector regressors for short-term wind forecasting was doing very well. The error was very less, and we were able to increase the annual electric output. Now, to maximize that, we tried different variants of SVR. Okay, so there is a twin SVR, least square SVR, epsilon SVR, and epsilon twin SVR. These are 4. Of course, now this work is few years. These data sets, this work was done few years back, but now there are even more variants of support vector regressor which people are working on. So from this we find that the root mean square error is, in terms of root mean square error, the epsilon TSVR and TSVR are doing good. Why we need to find the best algorithm? Because if we can find the best forecasting algorithm, our ability to have a less error, means promise and delivery ka jo gap hai, that will be less. So for this we need the best as possible, the best machine learning algorithm, and we find that in terms of RMSE, the epsilon TSVR and TSVR, they are doing better. In terms of now computational speed, if that is a very important criteria in some wind farms, computational speed is an important criteria where you have a lot of data coming in, which are generally when the wind farms are very large, where the wind speeds are the randomness of wind speed is high, where there are ramp events. Ramp event means when the wind speed, let's say right now it is 5 meters per second, and in 10-20 minutes it is 18 meters per second, because, and then let's say 22-23 meters per second, then you have to shut down the wind turbine sometimes before any tornado and things like that. So, but when there are ramp events, you don't have enough time. Okay, so in such cases, your ability, your forecasting algorithms ability to predict that becomes all the more critical. Otherwise, there will be damage to the wind turbine blades and things like that. Now, along with this, you can also see that there is this persistence algorithm. What is this? So persistence is nothing like is a very simple algorithm. It is not a machine learning algorithm. It's a simple arithmetic. Persistence says that, let's say I want to predict, let's say I have only 20 data points. So I have every 10-minute window, okay, what was the wind speed? Last 20 such instants. 10 minutes or 10 times 20. So last 200 minutes का एक sample ले लेता हूँ. And in that every 10-minute window, I am the average wind speed I am taking. Now I want to predict what is the wind speed in the 21st instant or 21st window of 10 minutes, right? So persistence simply means last 20 dispatch windows ka average you take, and then you say that that is the prediction for the 21st. Of course, this is a very simplistic, this is not machine learning. So you can see that in all the major matrices, this persistence algorithm is not doing as well as these. But if your algorithm, and sometimes it happens under overfitting conditions and other, when the data has some discrepancy, sometimes persistence will do better than some other algorithm. So that means you have to discard that algorithm, because persistence is the most simplistic algorithm that you can come up with. So your advanced machine learning algorithm has to do much better. So, and in this case, all of them are doing much better than persistence algorithm. Okay. And also we see that overfitting, which is a very important scenario many times we find in many types of data sets used in machine learning algorithms. We find that epsilon TSVR and TSVR, both of these, which are doing in terms of RMSE, they are root mean square error, they are outperforming. They are also able to overcome overfitting. So epsilon TSVR and TSVR are doing very good job in this case. This is more details. I will skip this. This is done. This test is simply analyzing the robustness of our model. Okay, so how good this robustness means that now I have done, let's say I have applied this, I have taken some data samples of last 20 dispatch windows, and I predict and I get that this model is better. But what about tomorrow? Tomorrow, if I predict and I get that some other thing is better, it can happen, right? So robustness means that if the robustness, this test, Diebold-Mariano test, if that is closer to a certain number, okay, it depends on the normalization. If it is close to a certain fixed number, you can know that means your ability to do one-time test and then picking a particular, let's say you say that epsilon TSVR is best. Tomorrow, if you do that test, you will again come up, if the test is really robust, you will again find that epsilon TSVR is indeed the best in another test also, right? So that is the robustness test. And we find that across all these data sets, okay, we applied this Diebold-Mariano test, and we find that yes, our model is robust. Okay, so that was forecasting. So to do forecasting, we should have a robust model, and then we should be able to find out which of our forecasting algorithm is doing the best job. Now, there is also I spoke about the patent idea that there are multiple wind farms which may be nearby, and I want to do some kind of bartering so that I don't pay enough penalty or high penalties to the utility. So for this, we apply a decision making algorithm. And like I said, there are, in this integrated solution, there are 3 parts. Wind forecasting I have just described to you in brief. I will speak, the objective 3 would be the wake management, but now we are doing this decision making. Okay, so what is this? Let us say decision making, the most simplest way of understanding is that there are some criteria of how you will decide, and there are some alternatives. Okay, so that means you can say this is an alternative I can take, this is an alternative I can take, this is an alternative I can take, and there will be some criteria of choosing those alternatives. So decision making is simply a technique to Of course, there are very advanced ones also in this, but to have a basic idea of decision making, that there are some alternatives that I will take. Okay, I have, and I will choose the one based on some criteria. Okay, so in this algorithm where I have multiple wind farms and I have to supply to the utility, these are my 4 alternatives, 1, 2, 3, 4. So what are those? Alternative 1, that means you pay penalty for every forecast error. You don't save to the battery, you don't take from the neighboring farm. If you promise something and you are now in shortfall, you simply pay the penalty. This is one alternative, of course, right? It may or may not be the best one. We'll see what after with using some multi-criteria decision making algorithms, which is the best one, right? But this is definitely a alternative. What is that? That means, and this is simple, very easy to understand. Let's say there are k dispatch windows, okay, k of them, and you have P hat is what you are forecasting and P is what you are actually delivering. Okay, so if you forecasted something and you are delivering something which is more than the forecasted one, means you said something I will deliver, and then actually when your time comes to deliver, you have delivered that much or more than that, then there is no penalty, right? So this P, if P is greater than P hat, then there is no penalty. So whenever the ulta happens, whenever P hat is greater than P, that means in any dispatch window, whenever P hat is greater than P, that difference you have to take, you have to add them up, okay, and then there is a penalty cost. Means penalty means, okay, this much power you have shortfall is there will be some cost, okay, that's that will be pre-agreed, let's say 80 cents or $1.5, whatever, that is the beta, okay. So the total penalty for all the dispatch windows would be this K may be something for entire year also sometimes, okay, or it may be done, this settlement may be done every month, okay. So whatever it may be, but if I say that I will not save to the batteries, means I don't need to invest in batteries, I don't need to do any dealing with the neighboring farm, then I will simply have to pay penalty. So this is alternative 1. What is alternative 2? Alternative 2 is pay penalty for using battery up to a threshold power. So like I said, if there is a heavy charging or heavy discharging, then what will happen? Battery life goes, battery is consumed faster, or battery life gets depleted fast. So I don't want to, so in wind farm management, ramp events are something that we don't like. So when you don't want ramp events, that means you don't want something like I said I will provide this much and now I'm providing very less. Okay. Or and why it is like that? Because I thought that my wind speed will be so high, let's say 18 meters per second, and actually wind speed is only 5 meters per second. So there is a huge gap in the power that I thought would be generated and now it is less. So what will happen is that I have to pay penalty, right? But if I choose this alternative 2, what I do is up to a certain threshold, means I don't do charging or discharging, very heavy. Let's say battery ka itna pura I take or almost entire surplus I pump to the battery. Instead of doing that, keep a threshold, okay? That means if the power is more than what was forecasted, okay, or what was promised, if that is more than a certain threshold, then only I do this. Otherwise, I do like before. So you see the part here, this equation is like this. But if it is more than a certain threshold, then I do something different. Okay, so this is alternative 2. Alternative 3. And this is where our idea or the patentable US patent that we got is, based on this, I guided one PhD student and one MTech student. That PhD student is now a highly sought after machine learning consultant with Ernst & Young, which is the top consulting firm in machine learning. So that work is primarily based on this. Means this is the central theme of that. That means what is this alternative 3? Alternative 3 says pay penalty for borrowing deficit power from neighboring farm. Okay. So I take from neighboring farm. Let's say I have 3 farms. Okay. So if I take something from one and something from another one. I don't take a lot from a single guy, right? So that even the burden is shared, right? So if this is more than this, then this is the total cost. If P31 is more than P3 hat, then this is the cost. Otherwise, I simply do like before. Okay, this alternative, the second part is same in all of them. So this is alternative 3. Alternative 4 is like the alternative 1, but here I don't pay, means I use the battery. So pay penalty for deficit power using entirely from battery. Okay. So here I am in the first alternative, what I was doing, whatever was shortfall, I was paying the penalty directly to the grid. Means I didn't have to have battery. Here I am, whatever shortfall is there, I will take entirely from the battery and give. Means I will not give any penalty directly. Of course, I will pay penalty in terms of the battery life. Okay, so alternative 4 is, so basically to summarize alternative 1, 2, 3, 4, alternative 1 is pay penalty to the grid. Okay. Alternative 4 is simply pay from the battery life. Alternative 2 is that you do a balancing act. That means you, up to a certain threshold, you do this. Otherwise, you pay the penalty. Okay. And alternative 3 is that sharing from multiple wind farms. So that overall, no one is at any given point of time, no one is paying too much penalty or too much battery life consumption. Okay, so that now we will see using different machine learning algorithms. Sorry, not machine learning, using different multi-criteria decision making algorithms, we find what would be the best alternative. And we see, we apply, although now here I told you that this technique is not used in India. So then you should be now surprised that why I am also sharing this picture. Okay, so there are 3 different wind farms. Okay, and here actually this is a hypothetical scenario. This technique is not being deployed in India in any wind farms. But what I'm saying here is that if we do that, okay, we already did this in, I already showed you in these 3 wind farms, okay, Paxton, Bradford, and Bishop and Clark's. But what if we do this in these 3 wind farms? Okay, one is in Odisha and another is in Gujarat and another is in Tamil Nadu, deep south near Kanyakumari. Okay, so if we have a, this is an imaginary situation, if we have a grid, a national grid where we can pump this, okay, what will happen? So we did such a study. Okay, if we use this penalty based guaranteed wind power delivery from wind farms in India, what will happen? And we find that applying, so there are 3 different multi-criteria decision making algorithm that we use: SAW, TOPSIS, and COPRAS. Okay, these are today, these will be considered basic multi-criteria decision making algorithm. But we found that, and I will skip the details of this. I will just take you to this information, which, so here what I would want you from the wind farm perspective, what I want you to understand here is that there are some scores, okay, without going into the details of this because of limitation of time. These scores are helping us to do something called some ranking of these alternatives. These A1, A2, A3, A4 are the 4 alternatives that I spoke to you. Okay, so now using these scores, we find this ranking. And the interesting thing is that no matter whether I use SAW, COPRAS or TOPSIS, okay, we had the same result. That means alternative 3, that means sharing from neighboring wind farms, was the best one in terms of profitability. Alternative 2 means avoiding deep charging or deep discharging up to a certain threshold, do this, otherwise pay the penalty. That is better. And interestingly, paying the penalty was the third option. Using entirely from battery means forget about the whole world, just use battery to do charging, discharging is found to be the worst. Okay, even worse than paying penalty, even worse than paying penalty for every single time instant whenever there is shortfall. So you see that batteries have to be used. Now you may say, फिर तो battery use ही नहीं करना चाहिए sir, क्योंकि 3 is better than 4. But we see that when we do judicious use of battery, then that is higher ranked, that is number 2. And if we do bartering system, there also battery is used, but judiciously for not very deep discharge and charge. So then it is 1 is best, means then alternative 3 is the best. Otherwise, alternative 2, even when you are not doing this sharing business, if you do charging, discharging up to a certain threshold, then that is better. And this, the best part of these results is that it is agnostic to the decision making technique. You can see that in all 3 of them that we applied, we found the same rank. Okay, so it is established that alternative 3 is the best one. Okay, penalty paid for error in forecasting is higher. Okay, and battery activity is kept minimum. Battery activity have to be used. If I use only battery, we find that it is alternative, means the ranking is 4th, that alternative. If I ignore the battery completely, then all that alternative is 3. But if we use somewhat, no, means up to a certain threshold, then that is better than both of these. And if I do sharing with multiple wind farms, then that is best. Okay, so that's the second alternative. That means in this Venn diagram, which you have seen multiple times, the wind forecasting we spoke about, and now we spoke about the decision making. So these 2 are done. The third one is wake management, which will help in battery life, which will further help in battery life. Means if I do decision making, that is already helping in battery life. If I use proper advanced forecasting, that is also helping in battery life. But if I do wake management, then that will further help in battery life. So for this, okay, I have about 25 odd minutes left. So I need to introduce to you a little bit about what is wind wake. Okay, we're talking about wake management, but first, some of you may not be familiar with what is a wake. So basically, this is our free stream velocity, wind speed, right? So imagine you are in Somnath temple. Those of you who are from Gujarat, you would have, or even I'm sure Somnath being one of the Jyotirlings, and because we are in Gujarat, so I'll give you this example. Somnath temple is right next to the Arabian Sea. Okay, so, and why I take this example, because at the Arabian Sea, imagine some, let's say 100 nautical meters from the Somnath temple. It means you are in the Arabian Sea, but not very far. There, the free stream velocity is not disturbed by any building or anything, right? So that is this free stream V0. Okay. Now, imagine you have we are talking about wind farms. Okay, let's say 5.6 megawatt GE wind turbines are deployed, and let's say there are 52, 45. These are typical numbers of wind turbines that people generally have if they have enough space. When you have lot of wind turbines, okay, what happens is there is something called as a wake generated. What is it? That means, so this is the wind speed, right? This free stream wind speed is now acting on this wind turbine WT1. Okay, WT1, WT2 are two different wind turbines, right? This wind speed is impacting on this turbine, and then there is a formula for power generation from a wind turbine. So if this wind speed is not disturbed by any other object, then this entire wind speed will be available to me to generate the power. But this wind speed, when it is coming to this turbine, it is already impeded by this turbine. Now you may say that, sir, aisa kyun karna hai? Why don't we space out the wind turbines far enough so that everyone will be, and place them in such a way that everyone will get the free stream wind speed? Now that is not possible. That is only possible in an ideal world. Why? Because if you have, means the only scenario when this will also get you V naught as the wind speed is when the distance between these two turbines is at least 4 to 5 times the diameter of the wind turbine blade. So diameter of the wind turbine blade is the diameter. The radius is, when you from the hub, if you see, that is half of the diameter. So the diameter is this whole thing. So that's a lot of distance. If you take 4 times of that and then you place a turbine, that means you need lot of space, and land is scarce resource. So you will not be able to place, and if you place them 10D apart, then there is no problem at all in terms of free stream velocity. That means maximum power you can generate. You can, if you place them 10D apart, then what will happen is every turbine will generate the maximum power, right? So you can simply add the wind power from all the turbines. But that is not possible. Means there will be, in the downstream turbines, there will be reduction in the power generation because of wind wakes, right? So this is inevitable. Why? Because the distance cannot be increased too much because of lack of land space. Okay. So because of this, there is wind wake. Wind wake means this guy will be impeded by this turbine will prevent this guy from getting the free stream velocity 100%. Okay. Maybe 90% of that free stream will come to this. Now, so wind wake will reduce the total power capacity or generation of the wind farm. Now, what can we do to reduce that reduction? Means, let's say if this guy was able to get 90%, this guy is generating 100%. Okay, now, so overall is 1.9, let's say, if I just add it, if I normalize and add, so it is 1.9. I don't like it, let's say. If I want to make it 2, I cannot do, because 2 means they have to be very far apart. So let's say I want to make it 1.95. So what I can do? I can yaw these turbine blades. Okay. So those of you who are familiar with aerodynamics, there are 3 different angular motion: rolling, pitching, and yawing. Okay. So if you yaw the turbine blade, then you can, it is seen experimentally, okay, and there are many mathematical models also. If you yaw the turbine blade by few degrees, 4 to 5 degrees, you can reduce the wind wake. Okay, so we did this study. Okay, I will skip some of the details. Okay, I will make the, already actually sent to Professor Giri. I will request him, any of you who want these slides, he will share them with you. So we find that when there is no wake effect, your position is not changed. if I don't do wake management, then also that means wake effect is there, but I'm not managing the wake effect. Means I'm ignoring the reduction. So 1 and 1.9, let's say 1.9, I'm happy with that. So then also I'm not changing the yaw position. But if I do wake management, what does it mean? I'm changing the yaw angle by around 4 to 5 degrees. And we find that there is significant benefit in, of course, I will never be able to reach 1 plus 1. Okay. But the effect of wind wake is reduced using yaw angle control. Okay. And this we tested in two other. Now you may feel that why we are testing in 4 wind farms, 3 in Massachusetts, 1 in Spain, and then in India we are hypothetically considering that there are 3 wind farms, and now again in 1 in Australia and another in Tibet. Why we are doing this? That's because any algorithm, any technique you come up with, it has to be valid in many different terrains. Okay, here specifically this hilly terrain of this Longwan Tibet was very important to see whether hilly terrains, because there was a study which said that hilly terrains have in hilly terrains the ability to prevent wind wake is much less. But we found that using yaw control, we are able to, even for Longwan, and this is also another hilly, not so hilly terrain like this, but nevertheless a different terrain altogether. So we found that by using yaw angle control, we are able to improve battery life. We are able to save, you can see that percentage of life cycles of batteries, and this we have tested for 3 different battery rating: 500 kilowatt hour, 750 and 1000 for both these sets. Z1 and Z2 are this Chelium and Longyan. So we find that for higher BESS, of course, the percentage saving will reduce, but we can see that in hilly terrain, in fact, here we are able to save even higher than a wind farm which was not very hilly. So that result which is in literature before that, we were able to show that by yaw angle control we are able to do good wake management. So now I have talked to you about 3 different, means this Venn diagram. Yeah, this. So we started with wind forecasting, then decision making, and then this wake management. Okay. So now all these 3 together, if we do, we want to come into the center, that is this integrated solution. Okay. So here we have done a simple optimization technique. This technique, one can use some of the latest optimization techniques and improve this even further. But for our optimization technique, we were able to find, and I will now come directly to the results. Yeah, we used we had different weights for these 3 different costs to calculate a common metric. Okay, and we find that for different, these are again, and we also checked it at offshore and onshore wind farms. Offshore, see, till now whatever we described about wind farms are all onshore. Onshore means on land, the wind turbines are on land. Okay, but nowadays, in fact, in the last 10-15 years, there is also a big thrust in building wind farms in offshore. That means in the sea. Okay, far away from land. One of the reason is, of course, the initial infrastructure is very expensive, but once you are able to do that, after that, the ability, because there the land is not that much of an issue, so there the wind wake is not that much of an issue. You can place them apart, very far apart. Okay, of course, that doesn't mean that it is less costly. The availability of the sea is there. That's all. But we tested it, these forecasting algorithms, for both kind of 3 offshore and 3 onshore wind farms. And we find that the TSVR forecasting algorithm gave us the best result. Okay, the cost V1 that you see over here are these 3. So cost of forecasting, cost of decision making, and cost of wake management. Okay, then we give different weights and then calculate the total cost. So here we found that TSVR is best in terms of V1. In terms of V2, this was very interesting, that it is to find the threshold. Okay, so we found that this reduction, the pattern is very uniform, but it is not that it monotonically increases. After, if you especially if you see here, okay, when you do up to 0.8, 0.8 here means 0.8 of the battery's life, okay, or full charge and discharge. So 0.8, if you go beyond that, you see that it is not reducing anymore, it is increasing slightly. Okay, so we find that this V2 is found minimum, this ratio is at 0.8. After that, again, this will increase. So there is a minima point for at this 0.8 threshold. Okay, so that means what? Again, it means that the recommendation is don't charge the battery to full and then again discharge. Don't do that. Keep it around 70, 80%, 90% in that range. And in this particular case, we found 0.8 to give this minima point. Okay, so that's V2. And in V3, that is the cost with wake management. Also, again, here also we find that the TSVR is better or lower cost across all the 6 wind farms, offshore and onshore both. Okay, so now all this is fine, the TSVR, and it is clear that that algorithm is better. But what about battery life? So the number of distinct battery state changes, if I apply, okay, gradient boosted machines, random forest, TSVR or epsilon TSVR, okay, we find that these are giving much higher number of cycles. Okay, whereas TSVR and epsilon TSVR is also good, but this is best. And overall, you can see that for all the 6 wind farms, this turns out to be the best. Okay, so now choosing, I said that there are 3 different weights that we take, H1, H2 and H3 for these 3 costs. And so we choose some value here. If we take H1 and H3 to be 1 and H2 to be 0.84, we find that still TSVR is best. And if you take something else in H2, again, the change is not that much in the values. But nevertheless, whatever you take, the TSVR turns out to be the best overall metric or best forecasting algorithm. Okay, so that was it actually. This summary of this here I have already spoken. A little bit about the future work I would like to state that some work can be done, some people are doing on the effect of terrain, that means surface of the wind farm, that can have some effect on forecasting. We are this thing which is future work stated here, we have done some work in this, that predictive analysis of turbines we can integrate into this, that health management ahead of time, can we forecast that when a particular turbine blade will have some crack in it or some ice deposition, so power generation will be reduced, can we predict some of these? Okay, so that can be integrated into this solution to do better forecasting for better battery life and things like that. So, and when many people do these dispatches, there can be congestion management issues that needs to be dealt with. So anyways, I think I have around 12 minutes left, I would like to make it available for some questions that may be there. Professor Giri?
Yes, sir. Yeah, we will take few questions now, and just I will look into the chat box. Yeah, actually, there is one question.
Yeah.
Dr. Sundaram Pandya has asked, which model is better for renewable power forecasting? And Webull PDF or machine learning based like SVR?
Webull. I think he is saying Webull.
Yeah.
Yeah. So Webull is a very, for wind, Webull is a more than Gaussian distribution. For wind, Webull is the best distribution. But here we are talking about, we are not talking about the wind speeds distribution. We are talking about the ability to, means it's like you promise something to your wife that I will buy you this thing and in this Diwali, and you, the test is how far away were you from that. Did you fulfill that promise on that day, or did you fulfill it after a few days of that, or did you forget completely about it? Okay, or did you forget the birthday? So things are, the cost involved are very different based on how far off you are. So here it is not about the distribution of the wind speed itself. It is about how much I said I will deliver. Wind speed means how much power I said I will deliver and how much I actually delivered. Or the error between that, if it is less, then my cost or the penalty is less, and if penalty is less, my overall power, overall profitability from the wind farm is high. So here it is, the distribution of the wind speed is not the factor here that much. Here the factor is, see, if I want to, let's say, you may say that one question may come that you are saying that I promise this much and then I deliver this. What if I promise less only? So if I promise very less and I deliver, it seems it will be good. No, because if I promise very less, I will not be competitive. Okay, my profitability will be reduced. So the trick is how the ability to promise as much as possible without having to pay very high penalty for missing that target. So in that context, we find that these TSV, or the twin support vector regressor, TSVR, as you can see consistently, is better in forecasting this. And not only in forecasting, you can see that TSVR is better in wake management also. TSVR is better in the forecasting also. In 2 out of the 3 things, TSVR is better. You can directly see from the table, and you can see that with 0.8, when we did this, we find that in all of them, we found that, and overall when we do the accumulation, we found that the TSVR technique is better. So if the question, if we want to know which technique gives us the best result, that is TSVR.
Okay, sir. Thank you very much for your wonderful answer. And the second question he has asked in continuation. Wind wake effect study is not done before wind farm layout design?
Yeah, no. Wind wake study is done. Always it will be done before the design. But the challenge is, so that is what is that, let us say you have so basically what will happen, typically what will happen, you will have a certain area of land, you will want to put a certain number of turbines, if you now the optimization is this. If you now study says that if you put 4D apart all the turbines, then you can maximize the you will have negligible wind wake. Okay, but 4D is not possible. Okay, generally you can only achieve 3D. Okay, something like, and also you will have a certain area of land, you cannot be too close to the boundary, those turbines, because then chances are your turbine will be blocked by some buildings or this kind of thing nearby or whatever. So you want to, so some spacing from the periphery is also required, some spacing from each other is also required. Okay, and that is why, even though the study is done ahead of time about wake management, but it is also found that if you have a variable, if you can vary the yaw of the turbine blade, you can reduce the wind wake. This now, once the study is over, once you have put all the turbines in those locations, after that you cannot improve the wind wake condition, right? After that, only way of improving it is by doing yaw angle control. So the yaw angle control means it is like that this guy is seeing a wind speed, this guy is also seeing, but this guy is oriented slightly different, so that the ability for this to see higher wind speed is more. That is the thing. Means in 3 dimension, it is not impeding as much if you just yaw the blade little bit. I hope that it makes sense. Means if you just give a small yaw angle, because it is in 3D, the wind speed that is coming onto the downwind turbine is slightly higher, generally few percentages more. So the summary of this answer is that even if you have done an earlier a complete study before installing the turbines, after the turbine installation, you cannot completely eliminate wake, right? But after installation of the turbine also, you can do yawing to further reduce the wake. Okay, and that yawing is not predetermined, by the way. It depends on the specific wind speed, it depends on the wind direction and things like that. So you cannot do this ahead of time. It has to be done in real time. Based on wind speed and wind direction, the yaw angle will be very different. In this particular case, we found 5 degree yaw angle to be better. But in many other studies, anything from 3 degree to 11 degrees people have found for specific terrain, specific wind speed direction and things like that. They have found a specific yaw angle to be, if you do completely real time, all the turbines are yawing at very different angles, that will be much more data intensive. If you want to come up with a particular yaw angle for a specific wind farm, that can be done. It will reduce the wind wake, but that has to be done after, means it has to be done for case by case basis, because the wind directions will keep changing, wind speed will keep changing and things like that. Only the terrain is fixed after you have done the installation of the turbine. Any other questions, Dr. Giri?
I hope so. Queries are answered very much in very much satisfactory manner, and most of the things were very much clear from your session, sir. You delivered your session wonderfully, and clarity was there around 100% from my point of view. There was not much confusion in the session, and I hope so participants have enjoyed your session. You have given your valuable time to us. Entire GEC Bharuch is very much thankful for your effort and time. And now
Dr. Giri,
I would like to
make the slides available to all the participants.
Yeah, definitely, sir. Definitely. I will share it immediately after your session.
Sure.
And now I would like to invite Professor Jatin Chaudhary to say summary words about your session. Professor Jatin, yeah, you
Yes.
are audible. Yes.
Thank you. Thank you, everyone.
Thank you, sir. Hare Krishna. And I wish you all the best for your time ahead. I wish your faster recovery. I know you were not fit since last few days, but you accepted our invitation during your ill health also. That shows your commitment towards the technical fraternity. You have wonderfully delivered the session here also, as Professor Chaudhary already said about the session. Thank you very much, sir. Hare Krishna, and hopefully we will meet.
Thank you. My pleasure. My pleasure.
Very soon. Thank you. Thank you very much, sir. Thank you. And thank you very much, Professor Stephen, for joining till this moment. Thank you. Yeah, yeah. And
thanks, Steven. Thanks.
Yeah.
Thank you. Thank you.
now we'll start our next session with Professor Sukumar Misra very soon. Professor Misra is the director of ISM Dhanbad, now IIT Dhanbad. Hopefully, Professor Jatin, you check in the list whether sir has joined or not. Not in this meeting till the moment. Dipankar sir, if you have time, you can stay to just that means just to say a few words, and just you can talk to Professor Misra. He is about to join very soon. Professor Misra sir is joining us within few minutes. I had already discussed with him. And dear participants, you can ask questions as much as possible so that there should be a great interaction between expert and participants, and sessions would become interactive. If someone is interested to talk something or their findings, they can raise hand. We will allow your camera and mic. You can also share your expertise, because so many of the participants are teachers, researchers in their own field. It is not like just we are the speakers. You can share your expertise as well. If someone is interested to talk something during the sessions or after the sessions, just you raise your hand or you can write in the chat box. Immediately we will enable your mic and camera, and we will provide you the platform to share your expertise with all the participants. So if someone is interested, we can allow. I hope so. I am audible to all the participants. Hmm, I think Misra sir has joined us. Dear participants, there is some joining issue to Misra sir. We are sorting it out. Just you keep joining, please. Hello, Misra sir. Are you hearing me?
Yes, able to hear you.
Yeah, sir. You can turn on your camera as well as audio. Yeah, thank you, sir, for joining us. I am sorry. It was that means some problem from your side. It may be difficult first time, but I hope so. You have joined, sir, and thank you very much for joining. And now I would like to introduce Professor Dr. Misra, sir, to the participants.
Sharing के लिए we need permission to share your screen.
Yeah, actually, you just see at the top of the right side, there is one share.
That I have done, but after doing that, this is the thing that is it is asking. And
Sharing permission is given actually.
Share.
And then go into entire screen.
Okay.
And
now are you able to see my presentation?
Still not, sir. You share and then entire screen. Yeah. And then you can you go into folder and open the presentation file.
Exactly same thing I'm doing. Choose what to share with team, entire screen, and I am now sharing. It is not getting shared.
Yeah, it is not coming, sir.
और एक बार लीप करके ज्वाइन करूं क्या?
ऐसे तो प्रॉब्लम नहीं होना चाहिए. आई थिंक सो. जतिन सर, जतिन चौधरी. हाँ, थोड़ा सर को बता दीजिए, थोड़ा सा कुछ डिफिकल्टी आ रही है. वो एंट्री तो कर लिए हैं सर इज इनसाइड, but sharing in the presentation is somewhere problematic. Yeah, sir has again entered into our meeting.
Recording has started outside your organization. इसको दोनों को close कर दिया. Recording has started को close कर दिया. Then now I am going to share. Share window, screen window. Then entire screen. Then share. We need permission to share your screen. Go to security and privacy, screen recording to give permission to start sharing. ये क्या है?
जतिन सर जरा देखिए.
Screen recording to give permission and start sharing. Yes, sir. तो मैं आपके पास भेज दूं क्या? आप आपके साइड से शेयर करो. नहीं,
हाँ, ऐसा करिए सर, वो भी ठीक है सर, कोई बात नहीं. प्रशांत शाह सर, प्रशांत शाह सर, पीके साहब.
यस.
ये प्रेजेंटेशन सर का आ रहा है, तो यू प्लीज शेयर फ्रॉम योर साइड एंड स्क्रॉल द पीपीटीज.
Yes. You can send me WhatsApp, Giri sir.
हाँ. Sir will send me. Yeah, sir has already shared with me. Now I am sharing with you.
Just wait.
Now, Professor PK Saha, it is available to you.
Just a minute. Hold on, please.
Because I have to go somewhere.
Yeah.
Just a minute, sir.
PK sir, please do it fast.
Yes, yes, just a minute. गिरी सर आपका पीपीटी आया नहीं है?
अरे व्हाट्सएप पे भेजा भाई,
मैं 8:30
व्हाट्सएप पे भेज दिया है.
Just a minute. Just, yes.
Now, meanwhile, I would like to introduce our eminent.
पहले से आप करिए जल्दी जल्दी.
हाँ
तो
सर,
introduction.
Hello.
Yeah, I have to leave at 8:30.
Okay, sir. Okay, sir. Just I am very briefly introducing my participants. Dear participants, today a very distinguished guest, Professor Dr. Sukumar Misra sir has joined with us, and sir is working as a director, Indian Institute of Technology, Dhanbad, and an acclaimed researcher and effective administrator, and has carved a niche for himself in the field of electrical engineering. As a part of administrative role, he has served as Dean Research and External Engagement, IIT Delhi, and there are many awards in sir's credit. I am not reading now due to lack of time. So, sir is also the founder of Silo Solutions Private Limited under the Companies Act 13, and sir has done a lot of research in the domain of electrical mobility, electrical engineering, microgrid, and its operation and control. Now, directly, I would like to invite sir for taking the stage. Thank you very much, sir, for joining us. Thank you. PK sir, please share the presentation.
Just a minute, Giri sir. Some issue is just a minute.
क्या आ रहा है भाई? फाइल नहीं खुल रही है?
1 मिनट में जतिन सर को भेज रहा हूँ. 1 मिनट.
अरे यार, क्या प्रॉब्लम क्या है?
Hold on, please. Jatin sir, please try.
So in the meantime, anybody is having any doubt, you can ask question.
Yes, sir.
Any participants?
Participants, if you have any query regarding to the contents related to this training, you can discuss with sir. Sir is available to us. You can keep your questions in the chat box. I will put forward in front of sir. You can ask, please. You can interact with sir. It's your golden time, whatever sir has given to us. Due to sir's.
Jatin Kumar,
Yeah, very fine. Now, sir, it is available to you, I think so, presentation?
Yes, go for full screen.
Full screen. Yeah, fine.
Next.
Now, next.
So, good evening to all. And as we will be discussing about the grid integrated system, and in the solar photovoltaic sense, the grid integrated system, and we will see how the grid integrated system poses problem for the grid. As you all know, whenever we go for a solar system, as it is intermittent and uncertain in nature, the fluctuations of the solar photovoltaic power with respect to time creates problem, and hence we need a storage element. And normally, when we talk about a storage element, it is the first line, which is the battery, comes into picture. And in the battery, we all know that it requires a lot of investment. So the grid integrated system plays an intermediate thing where the grid acts as a storage. If I look to a grid as a black box, I see that there can be power output from the grid and there could be power input to the grid. That means I can supply power from the grid to the load, which we normally do in our household. Similarly, I can supply power from the photovoltaic system to the grid in the grid connected mode. So this grid connected mode of operation plays very vital role and try to minimize the solar photovoltaic installation cost because we can avoid the battery in the first go. But as we go higher and higher into the penetration, lot of problem occurs and maybe in future we require a storage element because we know solar photovoltaic or any renewable energy system is not 24/7. It will have its own limitations. Therefore, in the research, people are now again focusing on 24/7 electricity based approach and particularly the small bidder reactor, which is coming in nuclear system, is playing a very vital role. And in future, the microgrids that will be formed can have nuclear power reactors in few kilowatt to a small range in megawatt. So this type of operation can be there and a transactive energy between these microgrids, which is consisting of local load and local generation, will form a bigger grid. So a lot of paradigm shift will happen in the smart grid domain, especially when we look to the solar photovoltaic integrated with rotating machines, which is in this specific case, the, the nuclear power system, as I explained to you. I will not go into the rotating part aspect of this overall discussion point, but I will only concentrate on solar photovoltaic system integrated into the grid. Next. So, as you see here, the solar photovoltaic system, when connected to the grid, will have a load and a grid. The load is nothing but your household load, and the grid is nothing but your point where the meter has been connected. So the meter, normally when we go for a solar photovoltaic integration, is replaced by a net meter because we may require to know how much my solar photovoltaic power is in feeding to the grid and how much I am drawing from the grid. So based on the load magnitude, either I will draw from the grid or I will supply it to the grid. So this gives a hybrid mode of approach where both grid and solar photovoltaic becomes complementary to each other, with, other than becoming a competitor to each other. Next. So in the grid connected mode, when we do, the most important aspect is the maximum power point tracking, because the solar photovoltaic system will be a renewable based approach and the photovoltaic panels are costly and hence we need to go for its maximum power extraction. So the algorithm of MPPT is to be embodied inside the solar photovoltaic inverter, that is the smart inverter. PPT is not visible. Is it visible now?
It is visible, sir. Visible.
Okay. So the the MPPT, the maximum power point tracking, is included in the inverter, and that inverter tracks the maximum power. There are many algorithms, multiple algorithms, hundreds of algorithms exist to extract this maximum power. And the newer philosophy is this flexible MPPT, where flexibility means wherever you want to have the power output, you will keep within the boundary of maximum point to that of the open circuit point. So under that circumstance, the PV system act as a current source from the grid point of view, because the grid voltage cannot be altered. So to a voltage source, which is the grid, we cannot connect a voltage source again, because two voltage source cannot be connected directly. We need some impedance in between. However, to a voltage source, we can always connect a current source in parallel, and the photovoltaic system acts as a current source in feeding current to the grid. Now, as the grid voltage is a sinusoidal voltage, we need to synchronize the grid with the PLL, with the help of PLL. So the inverter need to be synchronized with respect to the grid, and hence the waveform of the grid voltage is captured or regenerated using the PLL, that is phase lock loop, and the PLL acts as a synchronizing element, or you can say that it is equivalent to synchroscope in case of thermal power station. So when the grid fails, the PLL sends no signal, and hence inverter may fail, and in some circumstance it may go into resonance. And under that circumstance, when it will go to resonance, it will be acting as a source, and we need anti-islanding detection in the inverter to take care of that. So in multiple cases, you may see that the photovoltaic system, therefore on the rooftop of academic building, does not work when the grid fails, and we need to operate a diesel generator set which will synchronize with the system, and the photovoltaic will start producing power along with the diesel generator. The diesel generator cannot absorb the photovoltaic power. Hence, it will always go into the load side, or the consumption has to happen. And hence, there will be a requirement to coordinatedly operate the DG and PV in a proper way so as to make the system stable. Next.
Next slide, Jatin sir. Slide is not rolling. Yeah. Yeah.
So as PLL is basically an equation, it is having a mathematics in between. The mathematical stability of the PLL is very important. That means when there is a change in the voltage magnitude and the frequency of the grid, the PLL may differ in its performance. So based on what is the mathematics that you are putting and how the mathematics has been written, the dynamics of PLL will vary. That means the rise time, settling time, and many things will vary. And because of this variation, there will be issues in the stability conditions, and the inverter will enter into an unstable situation, maybe if the PLL mathematics is not properly written and analyzed. Hence, in a grid connected mode of operation, the PLL dynamics is very, very important. And to avoid this, design of PLL should be carried out such that it will be fast, robust, and should be tested for all possible dynamic conditions. Next. So as I have told you, there will be a MPPT point and there will be a flexible MPPT point. So you can see here, the peak is your MPPT point and the P1, which is the less MPPT, is your flexible MPPT point. So by adding a delta V to the DC voltage control equations and the reference value of DC voltage control loop, you will be able to operate the power at any desired point. And that is called as flexible MPPT mode of operation. Next. So the flexible mode of MPPT is also called as derated/op MPPT operation. So it has multiple names. Some people told that it is derated mode of operation. Some people tell that it's op MPP operation. And some people mention it to be flexible MPP operation. So this is required just to mimic the behavior of synchronous machine from the solar photovoltaic grid connected mode of operation. Because as we see in a thermal machines, if the capacity of the thermal power station is 500 megawatt and 500 MVA, then we normally do not load it up to 500 MVA, but we load less than that. And that margin is called as reserve margin. And that reserve margin helps a lot to keep the grid stability intact. So that type of margin need to be obtained from the solar photovoltaic system, and hence the derated or flexible MPPT is carried out. Next. Next. Next.
Next, please. Jatin sir.
So, as we know that when a grid connected system exists, there will be a real power and a reactive power from the inverter. So, if we look from the solar photovoltaic perspective, the power that is generated from the solar photovoltaic panels will be always real power because it is producing energy. So that real power comes from the DC side and goes to the AC side. And there is a capacitor which is in between. So the capacitor voltage will increase if the input power minus output power is positive. That means if the input is more than output, then the voltage across the capacitor will rise. And in that case, your voltage of the capacitor will be increasing. So therefore, if we try to keep the DC voltage constant, and then whatever input power you are drawing, that input power will go into the output section. And that's why you can say that the DC voltage control keeps the real power balance. On the other hand, the AC voltage control can be required for the reactive power. However, in a grid connected mode of operation, normally we don't go for a PI controller as you are seeing, but we go for a droop control in the AC voltage. Therefore, the DC voltage control is normally followed by a PI. But in the AC voltage controller, we many a time just put a droop at the place of the PI controller. So VAC reference minus VAC or VAC star minus VAC, and just put a proportional control, not a PI control, and produce the IQref. So that way, the IPref and IQref are generated for the purpose of controlling the smart inverter. Next. 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 Yes. So when you go for a solar grid integrated system, then the 0% what is in the blue line is the case where there is no solar penetration. And you can see that the blue line starts from around 0.5 per unit, goes to 1 per unit, and then reduced. So the blue line is the line which is basically called as the load line, and the load, that is the load profile with respect to 24 hours is given. Now, as you go on increasing the solar photovoltaic power, the noon power or the midday power will start reducing, and you will get that the power will go on decreasing, and finally will reach to the point 0 at the end. And after that, when you go for a further increasing the solar photovoltaic power, it will enter into the negative region. So in this case, it is basically feeding the power in the opposite direction. So when the power feeding is in the opposite direction, there will be multiple protection issues and multiple other heating elements comes into picture, and hence the reverse power flow in a big way are normally not advisable. And when we go for that, you can see from the blue curve to the violet curve, you will be having a ramp rate which is higher and higher. So this curve is called as duck curve, and the shape of the overall load profile along with the solar penetration will be a shape which is equivalent to the duck of the duck of a system. So it is having a long neck and a belly. So this type of scenario occurs when you go for reverse power flow model. Next. This I have already discussed. Next. So another problem occurs that is called as voltage rise problem. So when the solar photovoltaic system is absent, normally in a feeder, when you go from transformer to the end, you will follow the blue characteristics. That means at the transformer point, if it is 1 per unit, as you proceed and end into the farthest point, the voltage will be reduced, and it will monotonically go on reducing with different slope. However, when you are going for solar photovoltaic panel, especially on the rooftops, this phenomenon will be reversed, and you will get a characteristics which is read in nature based on where do you put the solar photovoltaic panels. So that says that the feeder end point, which was a reduced voltage, will now go to an increased voltage in the process, and the culprit is solar photovoltaic penetration into the system. Next. Some question somebody has asked. Okay, what is that? Can you just elaborate? Can you speak?
Sir, question is, respected sir, due to integration of solar PV protection issues, relay coordination occurs. How to resolve this?
This is a big PhD.
Miscoordination occurs. How to resolve this issue?
So it is a total PhD problem.
Yes, sir.
Okay, those who want to discuss, let them call me maybe tomorrow or day after tomorrow at 10 o'clock. I will give them the answer, but it's not
Okay.
a 10-15 minutes answer.
Okay, sir. So, dear participant, you can contact Professor Dr. Giri, sir, to further communicate with respected sir.
Okay. So, the voltage rise phenomenon is a big problem in the system, and all these distribution companies are now facing problem due to this voltage rise. And the smart inverters, that is the solar inverters, if we make them smart, then they can also produce reactive power, and the reactive power they can absorb as well. So a coordination between the rise in voltage and the reactive power supplied or absorbed need to be done, and that will give rise to the solution as well as give rise to having more and more solar power into the system. Next. Now, when we go for the integration, and as you see that the power flow increases, there could be a case which is reverse of the power flow, which is also called as power loss in the system. So as your reverse power goes on increasing, the loss in the system will goes on increasing. Initially, as you start penetrating the solar photovoltaic system, the power will go, the loss in the system will reduce because the net power will start reducing and the flow on the cable will reduce. But as it is increased, the reverse power flow occur and the loss in the system will increase to a very large value. And this is a big problem because the cable sizing need to be handled properly. Next. Next. So, as I was telling, the increase in power loss can be handled by proper coordination of the inverters, and many research publication has also been done in that perspective. And coordination of inverter and capacitor can also be there to handle this loss, and the infrastructure delaying operation can be met. Next. ये क्या है सर? FOID. What is there in the chat box?
Hello.
FOID controller work better than PID controller. How we find the value of KP and KI of the MPPT controller in existing simulation? See, finding of KP KI value in any system is a quite tedious task and quite interesting task also. And there are multiple approach for finding the KP KI, and the easiest approach is to go for the time constant calculation of the filter inductor and its resistance, and from that you can now tune the kpki value of the current control. And if you tune the kpki value, then the voltage, that is DC voltage control, which is in the outer loop, will be controlled just by 10 times relationship. And similar approach can be also done for the reactive power control. And MPPT, there is no PI controller available normally. And the dynamic issue, the inertia plays a very vital role in any grid stability. So rotating machines are automatically having inertia which produced from the system of the rotation. However, the inertia is basically a issue when we increase the solar photovoltaic penetrations. And a non-inertial frame and non-inertial system may be coming into picture because there is no rotating machine. So this inertia, as it reduces, it will jeopardize the grid stability, and hence artificial inertia or synthetic inertia need to be embodied into this overall schematic with the inverter, so that the inverter will be now a smart inverter. Next. So this can be done because it is an inertial response. It can be done by controlling the real power of the system, and hence normally it is added as a factor with respect to frequency into the real power loop, which is the DC voltage control loop. Next. And last but not the least, the power quality issue. Go to the next. The power electronics plays a very vital role in improving the power quality as well as deteriorating the power quality. If your control is not proper, it will make the power quality worse. But if you have a good controller, it may improve even the power quality. So the inverter which you have connected to the grid can now also act as an active filter, and it can help reduce the harmonics in the system. Next. So using this philosophy of the derated mode of operation and making it dynamically available for the inertial response, we may be able to sell the emergency power which is there in the system to go for ancillary services, and the photovoltaic generator which is grid connected will be providing the ancillary services to grid operators. Next. So this is all about my discussion point on the grid integrated system and solar photovoltaic. Due to time paucity, I have gone in little bit fast way because I have to also go for another important meeting. And maybe any question, if there is any, we'll discuss and we'll close it.
Thank you, sir. Thank you for your wonderful session. And I hope so participants have enjoyed a lot. Dear participants, sir is available for a few more minutes. If you have any query, it is the golden opportunity to ask directly to sir. In the chat box, sir has already answered the questions put in the chat box. And I hope so participants are quite satisfied, and most of the things was clear in your presentation, sir. And entire Government Engineering College Bharuch, principal, head of department, entire organizing team is very much thankful for your time and efforts put in to make the presentation. And you have given your valuable time to us, sir. We are very much thankful to you for joining us.
Thank you.
Thank you. Bye bye, sir. Thank you very much, sir. Good night. Dear participants, if any one of you to discuss something from your side, now we have 30 minutes more due to time limitation of Professor Misra, sir. We are having 30 minutes more and we can discuss. If you want to share from your side, just you raise your hand. It is the interaction time now. I would like to invite some of the senior participants and my friend Professor Yogendra Arya, sir. Yes, Professor PK, sir. You want to say something?
Oh, no, it was by mistake, Giri sir.
Okay. Any participants, if somebody wants to share, if want to say, or even it is also, you can say it is a networking time. We can communicate to each other if you wish. Professor Hemang Pandya. Professor Hemang Pandya, are you listening me? Dr. Sombir Kundu. Dr. Sombir. Yeah. Allow mic for attendees. Allow camera for attendees. Now all attendees are unmuted. Mic and camera both are available to you. You can unmute yourself. If somebody, Professor Sheikh.
No, sir. Everything is clear and all these sessions are very good.
Hello. If somebody wants to share some technical discussion, if from your side you can share. It is the platform of learning. Learning may be mutual from any side. Dr. Sombir. Professor Pandya. Yes, yes. If you want to share, please unmute. Dr. Sundaram Pandya. Yeah, Mr. Prasad Pasant Joshi. You can share from your side.
Thank you, sir, for seeing my chat question. Actually, I'm working on single phase STATCOM 6 systems, and I wanted to know, is there any person who can further give ideas about different ways of battery parameter optimization, which the battery is attached on the LFDC side of the STATCOM. And also, is there any possibility to do further research in the STATCOM, single phase specifically?
That means you are working on single phase active filter.
Yes, yes.
And that means either it is grid connected or standalone system.
It is actually wind turbine based system. It is grid connected.
Wind turbine based system as well as grid connected, both.
No, sorry, sir. It is non-linear load with the wind turbine generated power is getting supplied to the non-linear load.
Okay, I understand. That means wind is supplying directly to the load, and you are controlling the distortion of the load, etc., through active power filter, single phase active power filter. That's
yes, sir. Yes.
Is it right?
Sir. Yes, sir. Yes, sir.
Oh, fine. It's nice. The topic is very nice. I have already published one transaction paper on this. You can go through. Are you a student of Arya, sir? Na?
Yes, sir. Yes, sir. Yes, sir.
Then you can go through the simulations what even sir have.
Yeah. Currently, I'm considering the classical control phase lock loop.
Correct.
Different types of phase lock loops.
Yeah. You will get definite help if you put your questions very specifically. That means where you are facing the problem. We can suggest some probable solution to you. Yeah, Professor Sundaram Pandya, you are already that means provided access to the mic and camera. You can unmute yourself from your side, Professor Pandya. Hello, Professor Pandya.
Hello.
Yes. Now we are listening to you.
Okay. Sir, I heard out that how we put the dummy inertia in a solar integration microgrid based system. Because the renewable energy resources does not have any inertia. That how we put the dummy inertia.
That means you want to ask about the flywheel mechanism and all those things?
No, sir. I am asking regarding with the stability point of view. Because
stability,
the
yeah. Dummy inertia actually. Yeah.
Hello.
Actually, you see, if you increase the interfacing inductor, it will provide some kind of dummy inertia to the system, and that means if there is some current related issues, it may control the rate of rise also. This is one probable solution. That means when you are interfacing the inverter from the grid, you can just play with the value of inductor. Because
okay, sir.
Inductor will provide you some kind of inertia to the system.
Yes, sir.
And my point is actually you share something from your side, and
what I
see, suppose
related in contact with the stability. When thermal power station, there is a itself that hunting it puts the inertia for the stabilization of frequency and voltage. But in renewable energy resources, how the dummy inertia is integrated or we put in dummy inertia? That is my question.
Yeah. I understand it. Basically, inverter will provide everything. Actually, suppose whatever the things you are controlling in the inertial system, suppose voltage and frequency control in synchronous motor or induction generator or induction motor, that means the same kind of control in a static system. Like you can obtain using the that means the converter operation. Yeah. Inverter or converter operation.
I got.
Yeah, that means you have to run two separate control loops. One will try to control the frequency of the AC side, another will try to control the DC link voltage. And once the DC link voltage is stabilized, inverter will play its role and it will try to control the voltage and frequency both.
Okay, sir. I got the answer. Means the inverter is responsible for the controlling all these voltage and frequency related issues in terms of
Yeah,
inertia.
yeah. It will work
Okay,
as a
okay,
virtual generator.
okay. It will work as a matlab inverter is actually works as a virtual generator. With the help of
Yes, yes.
inverter, we can nullify these issues.
Inverter as well as interfacing inductor. That means
Okay,
capacitor,
okay,
inductor, and switches. They will provide you the virtual impedance, virtual inertia to the system.
okay, sir. I got your answer, sir. Thank you very much for you enlightening me regarding with this dummy inertia point of view.
I know, sir. I know you are expert in your domain. You are
No,
asking.
no, no, sir. There is no any.
Anyone
Sir, there is
else?
always there is a. Thank you,
Yeah,
sir. Thank
yeah.
you very much for your kindness, sir.
Arey, thank you very much for asking and interacting. Anyone else, please? I want to invite Professor Arya, sir.
Sir,
Yogendra
Professor
Arya, sir.
Arya is there, sir. Professor Arya is there, sir.
Yogendra Arya, sir. He is from
Okay,
JC Bose
okay.
University.
Yes.
हमारा वो चेला भी नहीं दिख रहा है, सोमवीर किधर गया?
Ashutosh sir.
Yes, madam.
Sir, I just wanted to add with the answer which you have given to sir. That generally like batteries which we are using, that is also acting as a virtual inertia. Actually the control strategy where energy storage system is there na, like batteries are utilized to mimic the inertial behavior of traditional power generator, and that effectively provides stability of the grid frequency by quickly injecting or absorbing power when there is an imbalance between generation and load. So this may in microgrid system generally.
Yeah. If it is a standalone system, battery will also play its role. Though the things are looking like static, but actually again the things are controlled, and you see battery charging discharging activity will be controlled by converter operation.
Yes, the control
Ultimately,
strategy which we are using,
ultimately real and reactive power flow will matter most in the system. Whenever if it is needed to absorb the reactive power from the system. Yes. Angel Abhinaya is wants to ask something. Hello.
Sir, namaskar.
Yeah, namaskar.
Yes, sir. Somveer is there, sir. आप पूछ रहे थे सर अभी? Yes,
कहाँ थे यार?
अरे सर यही हूँ, सुन रहा था.
अच्छा. हाँ तो तुम भी थोड़ा enlighten करो भाई. You have done a lot of work in this domain. You share something from your side. See, this is the mutual interaction. You can put your. हाँ?
अभी सर वो लैपटॉप से कनेक्ट नहीं कर रखा सर, उससे मोबाइल फोन से कनेक्ट कर रखा है सर.
हाँ लेकिन ओवरऑल कुछ बताओ कि कैसे भाई बाई डायरेक्शनल क्या है रिसर्च स्कोप वगैरह इस पूरे फील्ड में माइक्रोग्रिड में. अरे भाई मिस्टर देशवीर पीपीटी इज नॉट शेयर्ड फ्रॉम वेयर इट विल बी विजिबल. इट इज जस्ट इंटरेक्शन सेशन. वी आर नॉट प्रेजेंटिंग एनीथिंग. Professor Desveer is asking about PPT. Hello?
Yes, sir.
योगेंद्र आर्या सर को बुलाइए, थोड़ा उनको भी इंटरेक्ट कराइए सबसे. Other participants, you can turn on your camera, please. Participants, make the 15-minute session very much interactive so that we can enjoy the question hour session from each other. If you are convenient to turn on your camera, then only you turn on. Otherwise, if you are at home, I know at this time people may be busy somewhere also. So you don't turn on if you are not convenient, but if you are convenient, you can turn on. देवांग कहाँ गया? देवांग परमार. शिल्पा मैडम तो दिख रहा है. Devang Parmar? Where is Devang?
He is there.
कहाँ है? देवांग नहीं दिख रहा है. हाँ ठीक है. ओके देवांग तुम शेयर करो, तुमने कुछ काम किया है अच्छा ना. You have done something regarding energy generation from the wind and back-to-back converter topology, how you have implemented the controls. You share with others. Do not share any PPT, just you tell in the form of storytelling. Unmute करो, तुम्हारी आवाज नहीं आ रही है भाई. Unmute yourself.
Yes sir.
Yeah, nice. थोड़ा सा बताओ कि तुम्हारा what you are doing in your PhD. Participants, he is my first PhD student in GTU. He has published 2 SCI papers and he is about to complete his PhD. I am very proud of him. All the participants, please listen him carefully. He will tell something in story form, whatever he has done. He is my beloved student, first student in Gujarat Technological University. Basically, my first PhD student completed. Dr. Sombir Kundu is here. He had done PhD from Delhi Technical University. And Mr. Devang will tell something about how he is implementing his ideas. Yeah, you can share Devang. 5 minutes में. Otherwise, दूसरा भी अभी हमें उसको सारिका को भी टाइम देना है. My PhD students will tell their story of PhD journey to the participants. Yeah.
I have implemented the control strategy for the PMSV with the grid connected system. In the back-to-back system, the role of the deselling is very much important. I have supplied the whatever generated power to the from the PMSV to the grid. With the there are the two main objective, power balance and deselling voltage control. So I have implemented the 4 different control strategy. In particular, the generator side and grid side. I have implemented the generator side vector control technique. Also, I have implemented the FOC control. And third one, I have implemented the with the less sensor control technique with the boost converter topology. In that way, I have controlled the smooth control of the rotor angle PMSV and output current of the PMSV and rotor angle. In this topology, I have also controlled the deselling voltage. On the grid side, there are many control to main objective to control the power balance at the grid side. Also the deselling voltage control. In the grid side control, I have implemented the leaky momentum control, adaptive control method. Also the Kalman filter control and least mean square control, normalized least mean square control. So this is my work back-to-back topology in the PMSC. And also I have implemented this all the control in the real-time simulator Opel RT in the HIL mode.
Very nice, very nice. And there are further scope in this domain of research. Participants, you can use such kind of topology. Even you can try to think about how to minimize the switches, how to optimize the control algorithm, how to maximize the wind energy generation. And there are many things he has tried at his level to the level of best. And you people can, that means he has just told the story how he has tried the things in his PhD journey. And I hope so you may have got some idea if someone is doing PhD. Now I would like to invite Professor P.K. Shah, who had just a few months back submitted his thesis in the GTU. He will share something about his story. Professor P.K. Shah?
Yes, yes.
Yeah, just you enlighten the participants, what are the further research scope in your journey?
Yes, yes.
Do not share anything, just you tell in the story form.
Hello, everyone. Nice talking to everyone. Actually, my PhD journey had been started way back in 2018, beginning of the 2018. I am doing the part-time PhD from Gujarat Technological University. My research guide is Dr. C.D. Kotwal from SVIT College. My topic is basically based on the grid integration, grid-tied PV system control, and basically it is a power quality and power management for the grid-tied PV-based system. And specifically, I have worked on the grid-tied PV system, not a standalone system. So basically, this grid-tied PV system involves a lot of challenges related to power quality and power management. So I try to touch upon these two areas, basically power quality issues for the grid-tied PV systems as well as the power management related issues. So you have everyone just before this end of this session, Dr. Sukumar sir, Misra sir has touched upon the grid-tied PV system basically. So my area is somewhat similar only, but I have worked in detail regarding the various power quality issues and power management related, like power balance, uh, power balance for the grid tied PV system when the whether the BESS is involved or not involved, whether only standalone when and the different types of loads are connected uh, in the system. That means grid is there, load is there, as well as PV is there. Something happens to PV, is PV is not available, then PV power is not available. And if in that case you have an active power filter or inverter based system connected to the at the point of common coupling, what will be the behavior of the system? And suddenly when the PV is available as well as the inverter based system is available as well as the load is available, what will be the behavior of the system? What will be the issues related to power quality or management? Same way, if all the three things are available, if load is not available and you have to feed the entire PV generated power to the system grid, and if load is not available, how the system will behave? And suddenly the load is there, and behavior of the load means different types of loads are there. Like suppose there is a non-linear load or a linear load, unbalanced load is also. So it's the basically different types of case studies uh, with different cases, and I have tried to find out certain results for different case studies and try to represent in the different journals, reputed journals. So I'm fortunate to have one paper with Dr. Giri also in this regard in the Springer publication, Springer Nature, as well as one conference paper. Some other paper is also there. So anyone is interested, they can contact me for further communication in this regard. Thank you very much, sir. Thank you.
Thank you, Professor Shah, for sharing your valuable insight about your work. It was very nice interaction. And now still few minutes left. So I would like to invite Professor Sarika Kanojia. She is working under the supervision of myself as well as Professor Suthar sir. So Sarika, you can also share your that means research findings and challenges.
Yes, sir. Yes, sir. So, good evening, everyone. Myself, Sarika Kanojia. I'm working under the guidance of Bhavik Suthar sir and Ashutosh Giri sir. Initially, I started with voltage stability, and actually, for voltage stability, I have done from the power system part. Half of my work is related to power system, and now I switch over to the power electronics part. So initially, I have found the optimal location of EV charge stations, because nowadays EV charging is very much in popular. So I have found I have made one methodology by using two methods. I have hybridized the method, and using that hybridized method, I have found the optimal location of EV charging. After that, whatever voltage stability issues have been done, because I have taken the constraints of voltage stability there. the different indices I have considered as an objective function. And based on that, whatever issues are there after integrating the EVCS, I have found again by using one of the method the optimal location of solar, and after connecting solar, the how the voltage stability is improved in a distribution system. Actually, I've considered a distribution system, and first I have integrated the load EVCS as a load. Then I have connected the PV after finding its optimal location by one of the method. And now I have switched over to the power electronic part, where I am working on again grid connected PV system, and how this grid connected PV system affects the voltage stability. I'm working on that, and under the guidance of Giri sir, I'm developing some control algorithm for the inverter, so that inverter will feed the reactive power into the grid to maintain the voltage of the system constant. So ultimately, my work is on the stability side, but it is a combination of power system as well as power electronic devices. So whatever,
very
sir.
Nice, very nice.
Yeah.
Do not tell everything in the open forum,
Yes,
but
right? because my paper is still under review. So after publication, maybe you can
just
get
you
me
give the research direction. You don't say your
Yeah.
actual anyway. Sorry, it was on lighter mode. You can share everything. There is nothing wrong to it. Right? The concept is not its own. That means personal property.
Yes,
concept is for the society, right? Now,
Yes.
Dr. Chetan Lad sir is interested to share something. Dr. Chetan Lad. Yes, sir. Your mic is available to you. Unmute. Your mic and camera both are enabled. It may be some internet issue. Anyone else who has completed his PhD and wants to share some research insight with the participants? Dr. Dikshit?
Yeah, sir. Can I share? Professor Sheikh.
Yeah, definitely, sir. You are most welcome. Yeah.
Thank you so much. Thank you, Giri sir, for giving this opportunity to share my research work. Recently, I completed my PhD from the GTU, and you can congratulate me within 128. We are going to receive the doctorate degree from the GTU. My topic was the state estimation using the PMU and SCADA measurement. So basically, it was the problem of estimation. So everyone, we know that the accurate estimation of a state or operating state of a power system is extremely essential for the security assessment. And for that, we need to estimate the accurate state or operating state of a power system. So I have done the conjunction of the both the measurement. First, I have taken the SCADA based measurement, and I have done the state estimation of a power system by using the standard IEEE system. But this SCADA system having some problems. SCADA system is very slow. Some of the measurement may be inaccurate. Some of the measurement may be missing. So for that, we cannot use this SCADA measurement, or we need some more hybrid measurement system. So I've used also the PMU based measurement system. And by using the mixing of both this measurement, I have done the hybrid state estimation of the operating state. So that was the first objective. I've done the research for this by using this SCADA measurement. Second objective was using the PME measurement. Third, by using the conjunction of both the measurement. Means what? It is a problem of mixer of a two measurement. So that was a new problem into the estimation domain. How to mixture a two different data rate. So that was the problem. And after that, I've constructed the robust state estimation by using the both the measurement. So that was the topic, and it was a good domain if you want to pursue the your research into the estimation or into the control system. So I hope this is a new domain. Anyone, any of the research want to pursue in this domain, please welcome your idea, or we can do some collaborative work with this research area. So thank you, sir.
Well done. And
sir.
Yes, sir. Yeah, please.
Yeah, actually,
Sir,
if there is someone is asking something, yeah.
Sir, Hardik here.
Yeah, you are welcome.
Yeah, thank you, sir. Sir, I would like to ask the Sheikh sir one question related to PMU since he mentioned it.
Yes, sir.
Yeah, so
Hardik, boliye.
Yeah. So as far as my knowledge is concerned, you have worked on a little part of WAMS, right? Wide Area Management System.
No, sir. Actually, what I have done, PMU is a part of a wide area measurement system. I know that,
sorry,
but my objective was something different. Because I have worked with it, because my topic was I was very much interested in a control system. So in a control system, the estimation is the best part. And you know that in a power system, to estimate the operating state or the state variable is very much essential. So before proceed with this variable, we need to measure it. So by measuring means what we need to predict the measurement are accurate or not. So first I have done the accuracy, the available measurement is it true or not. So we know that any measurement is not a true. There is a something error. So this error means what I use this SCADA based measurement. In that SCADA measurement, there is a some error because this SCADA based measurement may be having some inaccuracy. Many times it is a slow data rate. So this will not work. So we need to go for the one more type of the measurements and new type of the measurement that you have told in a wide area measurement, that is a PMU based measurement. So we need to take the help of this PMU based measurement. Now, what is the problem with the PMU based measurement? It is a very costly. You cannot install the PMU at every buses. So now we have to go for the trading, means what optimum selection of the PMU measurement. So I have conducted both these type of measurement, and I have done a new algorithm, hybrid state estimation using the PMU and SCADA measurement.
Okay. Wonderful, sir.
Sir,
though discussion is taking place between two members, but I hope so. All are listening this discussion and maybe finding some new insights. And it was a wonderful discussion between Professor Pandya and Professor Sheikh. So thank you for it. Any other participants if want to share something?
Sir.
Hello, sir.
Yes.
Yeah, this is Dr. Mir Bhatt from Charuset University.
Oh, so, yeah, welcome.
Yeah, so my area is completely different from this renewable integration and all. I did my PhD in high voltage insulation, specifically on liquid dielectrics of the transformer. So my objective was to understand about the streamer discharge physics that can be altered by implementing the nanoparticles into the transformer oil. So for that, I have used this COMSOL multiphysics software. And as of now, I'm currently investigating the influence of the magnetic field over the streamer discharges, inclusive of the impurities and all. And for the same, I have also published the paper in IEEE transaction. And obviously, I will be happy if one can join with me in this field. Then we can do the collaboration. Because this is the emerging area. Recently, I have read into the insulation magazine that though the magnetic field into the insulation is very, very small, but it has a strong impact when there is a deterioration into the transformer oil. So as of now, I am using the multiphysics software just to understand about the physics behind it. And later on, the hardware model can also be implemented to understand the actual physics behind the occurrence of the breakdown and all under the presence of the magnetic field. So that is what my idea. The second is the purpose of attending this FDP is just to know about what are the different challenges that the renewables can create to the performance of the transformer, because the transformer
being from a different area, how's your experience till the moment about this FDP?
It was really good for me to understand that obviously the power electronics is there. So that because of those power electronic devices and the components, obviously it may affect the performance of the transformer. So logically, I just want to understand about that, that how this can be affect the transformer behavior as well as the insulation inside the transformer, so that it can straight to this reliability and all. So that is what my objective is. As of now, I'm just understanding and learning this power electronics and the renewable integration.
Wonderful.
Also related to the electric vehicle, the phase change material and all. So that is what I am understanding as of now, and later on I will connect it with the transformer research.
Yeah. It's nice, and if you are adding some new research dimension in your area, existing area, it will be wonderful for other researchers also, and it will be helpful to you also. Any other participants?
Sir, I want to say something.
Yeah, Dr. Silpa, yeah.
Actually, somebody talked about virtual inertia. I was listening at that time. I have done PhD.
There is some internet
on the
issue.
inverter side, we can have. Okay. Just let me switch over to some other net.
No worry. You can speak. Now it is coming. Yeah, audio is coming.
Okay. Sir, I have worked for virtual inertia issue only while we are injecting solar or wind into the grids. At that time, as somebody discussed about that issue. And as you truly said, from the inverter side, we can have good control strategies and we can mitigate that thing. And I think Sarika madam or some madam has also told that energy storage devices are very useful. So that is also true. These two are very good hint or ideas for the participants if they want to work for virtual inertia to provide from the side of renewables when we are injecting. So just wanted to share this.
Yeah, thank you very much. Thank you for sharing. And yeah, any other participants?
Yes, sir.
Yes.
Hello.
Yeah, you can speak.
Sir, hello, sir. Myself, Dhaval Joshi.
Yeah, Mr. Joshi, बोलिए.
Yes. Actually, my
वीडियो ऑन करिए भाई, वीडियो ऑन करो यार. जोशी साहब, बहुत दिन हो गया चेहरा देखे आपका.
Yes, sir. So actually, yes.
My colleague.
Currently, I am pursuing my PhD, and within 1 week or 2 weeks, I will complete my defense. Actually, my area was somewhat different. It is about incorporation of power electronics and control system in drones, and the work is about the speed control of the BLDC motor. Over here, my number of participants have shared those ideas. I am listening those things. But one thing I want to add, that Asutosh, my main guide is from IIT RAM, but we can say the co-guide is Asutosh Giri sir. And sir is from power electronics, and particularly from background from that, we can say that in microgrid and other things. But in that drone area, sir has given me the very good knowledge, and because of that, I am happy to share that my one of the transaction paper in fourth review, and maybe I hopefully that will be the accepted. So the point is, Asutosh sir is very much helpful for PhD candidate, and he has a wide area.
You don't. आपको मैंने प्रेज करने के लिए नहीं बोला है. आप अपना रिसर्च इनसाइट शेयर करिए. You don't praise me. I know you are kind to me, but you just give the direction of further research in your domain to the participants.
Yes, sir. So one can do, if you have interested in particularly in power electronics, and you are something thinking about different domain, then one of the domain is you can incorporate the number of things related to power electronics in drones, particularly electronic speed controller as well as VLTC motor, PMSM motor, adaptive control system. Many areas are there, so you can explore in this direction. Thank you.
Even different observers can be implemented in this segment.
Design
yeah, right. Sliding mode observer and all those things.
Yes, sir.
Me and Professor Dhawal, that means Professor Dhawal basically has done a wonderful work in this segment. Just I was helping him. He was, I am very much thankful to Professor Dhawal for his kind words about me. Any other person, any other participants? Still there are 72 joined us. So I would like to invite some others. This is interaction time. No lecturing, nothing. Just interact with others so that somebody may listen you, somebody may get some idea. My purpose will be solved. If someone is interested to share, Dr. Pathak Dikshit. Yeah, Professor Dikshit, you are welcome. Unmute yourself. Professor Dikshit, you unmute, please. Hello, you are not. Hello. There may be some issue from Professor Pathak's side. Anyone from some, that means outer part, that means beyond Gujarat? Kirti Madan? Kirti Madan? Jayashree Patil? Hello? 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 MM Jagannath? Okay, I hope so. Now it is time to sum up. Yeah. Professor Chetan Lal want to say something?
Hello, sir.
Yes, boliye sir, welcome. Yes, Dr. Lal, you are most welcome to share something.
Yes. I would like to talk about EV charging stations actually. So I had visited few industries in connection with the EV charger development. And the ideas come up with, actually already many ideas are implemented in foreign countries abroad. But actually, when we are talking about the renewable energy and the integration of it with the EV charging stations, it's a big domain nowadays for the researchers. So few challenges are there which I had discussed with the charger developers, which they are facing, especially slow charging stations and slow chargers and the fast chargers, DC chargers, and how the integrations issues between the solar parks and the fast charging stations. So there are some challenges which I had discussed with them. Actually, I would not elaborate all that points right now here. But those who are working in these areas, I think these challenges are giving too many insights to the researchers for the integration between the solar parks or say renewable energy and fast charging stations, which are the upcoming booming domain even in automobile industries in India or electric vehicle industries in India. So that is what I would like to convey to all the participants.
Thank you, sir, for sharing your insights or learning from your industrial tour. And I hope so the persons who are working in this segment definitely may be useful. Your that means valuable insights what you have shared here. So thank you very much for that means joining till late. And I hope so you are enjoying all the sessions as well. And definitely whatever the things are provided from this platform, it is going to help to all. Thank you, Chetan Lord sir. Thank you very much. Yeah, Dr. Dikshit. Yes, Dr. Dikshit, you want to say something? Hello, Dr. Dikshit, you unmute yourself. Dr. Dikshit. Okay, at this note, today, yeah, if anyone wants to say something from participants. Yeah, at this note, dear friends, now we would like to complete the session. And I hope so you are continuing to enjoy. And hopefully there are 2 sessions tomorrow. One session will be taken by Professor Stephen Ojana from Czech Republic. And first session will be taken by Professor Samaraj Arya sir again. So good night to all of you. Good night. Now we will join again. And one more information is Professor Samaraj Arya sir will join 15 minutes earlier. So you all are requested to join tomorrow at 5:45. So this is one new information. Tomorrow session will start at 5:45. You keep your connections intact. Thank you very much for joining late today. And thank you very much once again from my bottom of heart for your cooperation. You have shared a lot of insights, valuable inputs to all the participants. Thank you. Thank you very much to all of you, dear participants, for your participation and active discussion. Thank you very much. Thank you. Now we can leave.